Yeah, well,
That's the goal. All right. It's 31, so let's start. Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to our second Ask Me Anything session with very special guest, Paul. He's an expert on MLOps, LNMOps. He has comprehensive courses on both. We can ask about it later. Before we jump to the questions, some mini house rules. Well, not mini rules. Just feel free to ask questions in the chat by sending us messages, or you can add your questions to the Q&A session yourself. You can find, this is Google Meet. You can find activities in the bottom right. There is a like triangle, square, circle shape. You can click on that and you can see the Q&A. We're not many people here, so you don't need to be shy. We can also have some polls during the session you can vote for. We aim for an interactive session, really, so please participate. Another thing, we are recording this session, so please be aware. All right. For those who didn't stalk us yet, and I want us to do a very quick intro, including two questions and answers. We will introduce ourselves, and I ask all my co-hosts to tell what they love about MLOps the most and what they like the least. Starting with myself, I'm Bashak. I work as ML engineer for about 5 years. I recently changed my company. I am now at Booking, the travel company. So what I love the most about MLOps is that it's inevitable. I mean, the world is shaken by AI, and without the operational part, you can't really get anything out of it. So this is what I love the most about MLOps. And what I like the least is that it's growing and changing a lot, and it's so fast. And I have this huge FOMO sometimes. Yeah, these are my answers. Maria, can you go next?
Yes. So I'm Maria. I'm in MLOps already for 7 years and in data and AI for 10 years. So I'm working currently at Autobus. It's a large retail company. And what I like about MLOps the most is that, well, it's a big growing field, and you have to be very creative. And it's always about puzzling different components of MLOps. And what I don't like about MLOps is indeed the madness landscape, all these tools that are emerging constantly, and trying to keep up the pace is quite hard for everyone. Raphael?
hey, I'm Raphael. I've been working in data and machine learning for almost 9 years now. And before that, I was in sustainable agriculture for 5 years. And for the past 2 years, I've started focusing more on MLOps. Yeah, what I like about it is that it's so challenging and diverse. There's always something new. There are many interesting people in the field, and yeah, I'm just quite curious by nature. So always something new to do in MLOps. And what I don't like about it is that it's so challenging and diverse. It's the same thing. Like sometimes it becomes too much in an organization or some new technology, and then you really have to step back and wonder, like, wow, how are we going to tackle this next one? So yeah, it's sort of a double-edged sword, I would say, but I really love it. I used to be in data science, did a bit of data engineering, and MLOps is like the perfect fit for me.
Paul?
Yeah, sure. I would love to continue this discussion. So I have been working with machine learning in general for over the last 6 years. I actually began as a software engineer, then transitioned to research until I actually discovered this landscape of engineering and MLOps. I believe in the beginning for myself, like 5 years ago, was a total mess. Like, what should I pick? And what the hell is AI actually? But what I love about MLOps is the fact that it automates everything, and it brings structure and organization in the land of AI, which is really, really, really messy. And I'm a lazy person and with OCD, and this, I know it's kind of naturally, it's kind of natural for my personality, I guess. And what I don't like about MLOps is this: everybody thinks something different about MLOps. Like what Rafael said once, where you draw the line between MLOps, engineering, software, and all of that. And it's sometimes kind of hard to know what people expect from you when you want to sell yourself as an MLOps or ML engineer. Because I work as a contractor mostly, and very often clients expect something very different from you, and it's very hard to pick your niche, right? How to sell yourself, and yeah, this is kind of confusing most of the time.
That's actually a very valid point, especially when it comes to titles and job descriptions. You see a huge difference for the same title in the description, and expectations can be actually limitless because there are limitless option of tools, programming languages, and yeah, all combined, it can be actually very diverse.
Yeah, I often see like everything on a CV, everything that's
Sometimes I do
possible, like, from software engineering to data science to ML engineering to MLOps, just all the tools out there. But I honestly believe that the client itself doesn't know what it wants, so it just put everything over there.
Exactly, it feels like they just Google it, and then all the queries come up, or they're putting in the job description.
Yeah, it was pretty funny. Our previous guest, Eric Riddock, he posted something on LinkedIn this week, and he said like, "I'm gonna teach you MLOps," and then he posted like about 140 things you have to know. Then people started adding more things, and I looked over at all those items, and I thought like, yeah, it's expected more or less in a sense, or at least half.
Yeah, it does
Yeah,
sound
that's-
about right, actually. We are doing the MLOps roadmap this week, and it's getting really out of hand, I feel. So it's relatable.
Yeah,
that's the exact feeling. He translated the exact feeling when you want to like structure what you have to know or what you want to learn and all that.
Definitely.
So we started receiving some questions already, and I would like to start with the first ones, if you are ready. Sorab asked, what are the best ways to avoid train serve skew? So this performance difference between training and serving.
So is it related to data or is it related to infrastructure? Because these are two different things. So I guess we would be great if Sorab data. Well, I think there are different tools that help you to monitor those things. So I think NanyML is, for example, one of the tools that is quite popular nowadays, and it's getting bigger. We also use NanyML, Tahoe.case, we do some POC with it. And it's basically about when you are retraining the model, how often you need to retrain the model. And it has a nanny model that basically is telling you what are expected errors on your data set, and if it's getting more above the threshold that you expect, then it can trigger a continuous retraining process. So that's something that you can do. But in general, it's not always possible to retrain, in the sense you maybe don't have all the data available, because you maybe need the whole week of data to actually retrain your model. Then you might look into some inconsistencies. Maybe there is something wrong with the data that you get. So it might be good to check with who is calling your API if it's an endpoint. But something is off. So at least, so monitoring is basically the way to go, and continuous retraining strategies. Some additions to it.
I actually have question on this.
Yeah.
Usually when you want to create your retraining pipeline, do you want to completely automate it or just have a dashboard and some alarms or warnings, and before actually retraining your model to you or another expert to actually look at the data and push the final button, like to automate everything but the final button that you want to push?
Yeah, I think I would go for that way actually, so that there is a person that needs to be somewhere in between in the process to actually for the model to make it to production. So the continuous retraining pipeline can be fully automated, but indeed you can include that manual step in between to actually do the checks for it to go live. I would never totally rely on it, because most often it's not per se, model retraining probably won't even help, because it's probably a data issue going on.
Yeah, I agree. An analogy I'm thinking of for this is there's an old Disney movie. I think the English title is called Fantasia, where Mickey is a wizard's apprentice, and he kind of knows what he's doing, and he sets up all these items to start working and moving for him. But when he turns around and he comes back, it has turned into a big mess. So I think that's true for machine learning solutions as well. Like if you try to fully automate it and you try to pre-plan it and sort of read in your book of instructions or think about it like, okay, this is how it should work, you're going to find yourself like having walked away from the solution, and then you come back and it might be a big mess. And it depends on the type of industry you're in, but the impact can be huge. Like whether it's retail or Amria, you want to say something?
Yeah, for sure. But I think the continuous retraining isn't intended to be completely automated. So I think the main reason for it is that you want to retrain your model, but only when you need it. So sometimes it's just very expensive to retrain your model. And even though you can do it every week, it doesn't always make sense to do it every week. So you only want to do it when it is needed.
Yeah, for sure. And then if you want to automate that stuff, it's quite hard to in advance think of all the conditions that you might want to have set up in there to do an actual retraining or not, like to make a decision. It's sort of an algorithm in itself that you have to build on top of your solution. So I would definitely say, in answer to the question, like always have the human in the loop. And once you get like a lot of experience, maybe eventually you could get something fully automated, but you'd have to take so many things into account that it's better to have the human in the loop at first.
And regarding this retraining algorithm, how would you tackle the situation where you don't have ground truth?
Yeah.
Because if you don't have ground truth, it's kind of hard to analyze what's going on.
So that's the whole idea of this nanny model. It's actually a model that predicts errors on the data without knowing the ground truth. And that's why it is actually quite nice. So basically what you do, you train your normal model, like a regression, let's say, and you know what the predictions your model made and what your actual mistakes are based on your model. So this is something that you are predicting now with your nanny model. So you train a nanny model where that is what you predict, the error. So basically then on newly incoming data, when you don't have a ground truth, you already can predict the error, and therefore if it is above a certain threshold, that's something that you can use to trigger things, which is very creative, I think, pretty cool.
And how would you monitor the monitoring model?
Yeah, so I think they have a number of articles on that. They even actually have course now on DataCamp, I believe, about that. So you can go and follow it. I don't think it is you really need to monitor that one. So they actually prove that you don't have to retrain that one very often. They have some strategies to mitigate that, but you don't have to retrain any model often. So that's the whole point.
I think this is okay. Paul, do you have additions?
No, I just wanted to say that initially I understood many
Ah,
ML, not
no.
nanny ML.
It's actually
But
many.
yeah, I actually read a few articles about what you said, and yeah, it looks really promising to solve this issue.
Yeah, it
But
works also pretty well. We tried it on demand forecasting, and it actually showed that we were retraining our model way too often, so we could save some money.
There's another question which might even actually follow up this continuous retraining. What can be some of the deployment strategies borrowed from DevOps and can be utilized in MLOps, and how to achieve them? So we can maybe talk about the deployment strategies, including automated retraining.
yeah, I guess here again we have to settle like more infrastructure wise or like software engineering wise on how to
Exactly. So I was also
This is
not
probably
sure.
software wise, not infra. Yeah, software.
But do they also mean what environments you use for it? Like how do you go about different environments in different branches? Is it something that you mean here, Sorab?
Yeah, environment and branch deployment.
Yeah, we had an article about that actually. So for data science, I think the difference with typical software engineering is that you need to have access to production data in your development environment. And that's something that is not always easy to achieve because you have security policies within your organization. And it takes some fighting sometimes to actually make it happen and make it possible. But in general, I think you, well, depending on your setup, usually from what I've seen, 3 environments must be quite enough. So you have a development, acceptance, and production environment. And in some situation, you may want to have non-production environment, maybe when you are also testing the infrastructure pieces. But if infrastructure is pretty much set up, I don't think it's per se necessary. So the problem often with the machine learning that you have model registries, and model registry must be one central thing. So that's probably a less common thing compared to software engineering. So you have a central feature store, probably central model registries, and the rest you have replicated in each of the environment. And it must be exactly the same. So infrastructure as code deployed exactly in the same way to different environments. And the data is the same because it's the same production data with read permissions to non-production environments. So basically you want to train and test your model in development and test with whatever you integrate it with an acceptance. So for example, if you deploy an API, an endpoint, and it must be on the website, then you want to test it with acceptance version of the website and must be acceptance version of your endpoint. And then you can move to production if everything is going well. And you have the way how you CI/CD pipelines look like also may be different depending on. It's likely that there is also a person in the loop that can promote things to another environment, and you don't want to retrain your model as well in different environments. So promoting in model registries would be then probably the way. Paul, some more ideas?
I just have more questions.
Of course.
How would you implement like the development environment? You will also like actually deploy it on your cloud or whatever infrastructure you use, or you will somehow simulate it in, I don't know, on your local machine or something like that?
Yeah,
So
I think
I guess it depends.
No, go ahead.
I guess it depends on scale as well. What I'm seeing a lot is that it is being emulated on local machines, but it only goes so far, right? So I think there are some trade-offs there. But if we are working with big data, I think, yeah, then it makes more sense that you'll have it on your maybe cloud or perhaps on-premises infrastructure. But Maria, you also wanted to say something.
Yeah, but in that case, I guess in the development environment, you have like for every specific branch to create a different environment, right? Where everybody can like test what they're working on, or just like only when you merge your code into the development environment, then you can test basically what you've been working on, similar to staging or QA or whatever.
Yeah. Well, I think feature branches only should go to develop. So you basically deploy infrastructure separately on each of the environments. You have 3 versions of the same infrastructure and the same data with read permission, so you're not replicating the data, basically. And you have so that's how we work with it. And we have feature branches. From feature branches, it can only run on pre-production or the test environment, development environment. Then you have maybe release branches if you prefer using them. Then from release, you can, for example, run on acceptance. And from master branch or main branch, it would run on production. So that's one of the ways to go about it. Or another way that everything is on one branch and it's just going through different environments. So I've seen multiple ways of implementing that. And I think you should choose for the one that is implemented in your organization. I think it's pretty much the same as DevOps, not very MLOps specific, except the data part and the registry and the feature store part.
I think we can pick it up another question. Thank you for the answers. This is from Ahmed. How can we have a smooth model deployment flow when we have separate data science and MLOps team members?
Is it not in the questions list, or
Yeah,
is it?
This is from the chat. This is from the
okay.
chat. Yeah.
Okay, I'll refresh it.
Smooth model deployment flow.
The other section, the chat section.
Yeah. This is from the chat, indeed. Yes.
Okay. Yeah, it's a good question. So when we have separate data science and MLOps team members, I think there are many answers to this, but I'm also curious to hearing one of your answers, Paul. What are your views on this?
Well, I was thinking, and I think this is very related to what we talked so far, I think, because and I think this is a very common issue in most teams. I also see it in my organization, and to be honest, we are still settling on a solution. So I think it's extremely necessary, like, to have a development environment where people can, basically, the data scientists can play with their models. But I guess that this is more of a question that data science that develop their models and want to experiment and find the best hyperparameters and all of that, and after they want to take that model and basically automate it and put it into the MLOps process. This is what you had in mind, Ahmed, or you meant a different thing?
I'm not sure if he's still here, but yeah, he is. Maybe also to share some thoughts. I think whatever your handover process is between data science and MLOps or ML engineering, I think one of the things you should aspire to is to make the gap between them as small as you can. So, okay, thanks for your addition, Ahmed. So the addition is that yes, this is the issue where there's always a delay and there's always miscommunications. So I totally agree. It's quite challenging, but I think the gap you have between these teams, you should aspire to make it as small as you can. The teams are doing different things, of course, and you're seeing in some organizations that is really just data scientists like throwing a notebook over the fence to a completely different team. So this can even be handover, like I've emailed you this zip file and the code is in there. And then the other team emails back again like, oh, yeah, it's not running for us or something. So the first step in handover, I think, is just the basics. Like you want to do handover through version control, where you can actually also use your handover to a version control to communicate properly. And I think another step is to make the gap smaller, where as in there's some standard process. So if data scientists are working in notebooks, if that's the case, then how are they delivering that code to the other team? It is nice if you can have some sort of template using maybe a repository template or cookie cutter to at least have like standard operating procedures and practices in place. Then another challenge, I think, is changing the ML solutions. Like once this notebook or whatever it is has been handed over, the machine learning engineers or MLOps team might like totally refactor the code, and it will become some package or some image, etc. So then you also have to think about like, how do we deal with changes, and are the data scientists still recognizing their solutions? So I think they need like a certain understanding of how code is going to look in production. And these are a few of the steps you can take to decrease the gap, and there are a few more, but I already see the others want to chip in.
No, I think
what I found very, very useful is to settle on a specific interface. Like you said about version control, but like I think it's extremely useful in addition to like GitHub, that you use a model registry, which is basically your version control for your models. Because after you do your experimentation, you as a data scientist, you will pick a specific model. And when you pick that specific model, you should put it in a model registry attached to specific metadata, like the model schema, where you very clearly explain what the model expects, what the model has outputs, how the data is processed, and all of that. And not in a data sciencey way, but you have to see the things from the perspectives of the people who you collaborate with. Because most of the time, software engineers or MLOps engineers have some idea of what you're doing, but they're not that mathy, and they're not that, do not understand in such depth all those basically how models work under the hood. So you need to clear, you need to somehow expose all of this in a very convenient way for them. As Rafael said, the communication after all. But what I found useful is if you use, for example, experiment trackers like weights and biases or MLflow or whatever, they kind of expose a way where you can communicate this stuff more easily. As I said, a model registry, an experiment tracker where basically you can take your best model and create a report out of it, where basically you can document all of this.
Yeah. I think what we were discussing is not really MLOps way of working though. So I think MLOps team must be providing MLOps platform as a service, and data science teams must be able to put models in production themselves. That's what you need to be aiming for. I know that there is always a transition period, so the tips that Paul and Rafael gave, I think, are very useful. But in general, I think data science team must be completely self-sufficient, and the MLOps team must be providing the platform and the framework for data scientists to bring models to production as fast as possible. So things like reusable CI/CD pipeline, the infrastructure that is standard for each project, and so cookie cutter templates that. With the cookie cutter repository, you create a repository that has all the permissions you need to deploy things wherever is needed. So you need to give freedom to the data science teams and basically embrace the whole MLOps culture. When there is a handover, there is no MLOps culture, in my opinion, because it's more like separate silos.
True. Also, educating data scientists to be more also trained on putting models in production or using these CI/CD pipelines. I think they can be they can become familiar with the infra-related tools and how to use them. When the MLOps infra team provide these tools or frameworks to them, they would already be ready to actually deploy models. This, of course, depends on the organization and how teams are structured. Sometimes in data science teams, there are already ML engineers embedded, so the team already has the capacity to actually deploy models independently. And sometimes ML engineers are in one team, as in like in the core central team, and helping data science teams to deploy their models. So I think at the end of the day, it's using right tools, be the right way of working, and the communication. I would summarize it.
But
Yeah,
I have a follow-up question on this.
maybe to add something to this before we go to the next step. I think the self-service
sure.
idea is really nice. It's sort of like the golden standard. But I also think it takes a lot of work to achieve. And in the data science population, there will be data scientists who will embrace it, and self-service deployment can become a thing. Like they easily deploy their code in the right format, and they add some Git tag, and it goes to pre-production or production or whatever. But I see similarity with self-service BI. Like it was also the golden standard, like 7 years ago, and some organizations did it perfectly, but to achieve it, you need like all the right stakeholders on board, the right resources, and then when it works like a dream, but it's not so easy to get there. I think you also need some skill.
Yeah, actually, my follow-up question was related to this, because Maria, you said that when you have a platform, yeah, then the communication is quite easy, because you show the data scientists, okay, this is how you need to write the code, this is how we expect to deploy it, and all of that. You can educate them and teach them quite easily. But what if you're at the beginning of your MLOps integration and nothing exists like platform-wise? You don't have like, you don't use Databricks or a big big service that on top of which you can build this quite easily. Let's say that you start from bare scratch. How would you approach this situation? Usually startups start here.
Well, if you are a startup, I guess you probably on some cloud already, or if you yet to choose some cloud, I guess pick a cloud. AWS, I guess, is most popular for sure for startups. And so on AWS, you could already build some infrastructure. There are tools that you can use for your MLOps. Well, not necessarily platform. You don't need a platform if you're a startup, I guess. But there are tools like SageMaker that you could use to train your models, to deploy your models. So I would say just start with whatever is available and only add some pieces if you really need to. I think you can already start with following best practices in the beginning and don't have these silos. So silos problem only exists in large organizations which already have a certain way of working. It's a different problem.
Yeah, and I think for startups, there are all the fancy tools out there, but I think if you have to make decisions, even if you don't have the tools, just make sure you have some form of reproducibility in place. Maybe for the data, it will be really hard, but on your part, with the models you have and the code you have, just make sure you have that at least. And I've seen models saved just in repositories, not too big, but quite big still. Like, yeah, it's far from perfect, but they were still there, the old versions, and it also works. So beyond all tools, just make sure you have reproducibility.
Yeah, I also think that's like the first step of MLOps that you should take into consideration. Because I had one startup where I work with, and just when I joined it, they told me that they have in production a model that works, but they lost the code. I don't remember honestly how they lost the code. So after they worked for like another 6 months just to reach at the point that where they were with that model in production, because they couldn't replicate it. They didn't know on what data the model was trained, on what hyperparameters and all of that. Okay,
And-
you can know what model
Yeah.
are you using, but if you don't know all the small details, your work is gone.
Yeah, that sounds familiar from startup land, and that's so painful. Like, imagine what resources went into that you have destroyed on the limited resources you're trying to build this company with. A great example.
Yeah, and since then, like any repository needs like some sort of data versioning, model versioning, config versioning, and
Yeah.
code versioning. I think these are like the 4 pillars that you need to take into
And infrastructure
consideration.
versioning too. You need infrastructure versioning.
Oh,
too.
yeah.
Yeah.
Yeah, but at least in my opinion, I there's like second in priority. Like, I think it's really important to do it, but if you don't have like enough resources and skills, like,
Mm.
or depending on the scale, because maybe in the beginning you start like with 1 or 2 models that have not that much traffic, then it's quite easy like to replicate manually. But if you start having like a big infrastructure, then yeah.
Yeah.
I think this was a really nice discussion. Thank you all, you two, three. I would like to pick up another question from our Q&A list. This is from Mohit. When we need to decide to use a third-party ML solution, NanyML, Bento, Techno for Feature Store, when deciding to put models into production, there will be some concerns around cost, security, scalability, maintainability. How would it compare to use the common cloud providers like GCP, AWS, Azure? I would actually like to start picking this question. I think there is not a situation neither nor. When you are on these public cloud providers, you can still benefit from these third-party solutions. What I have observed myself in big organizations, usually there is one cloud provider chosen to be the main one. And the resources provided by this cloud are usually whitelisted and easier to integrate with existing systems. And organizations, teams are likely to go with what's already given by that cloud provider. However, in my opinion, the approach should be more flexible. They should first evaluate what's out there in the market. If, for example, we need to choose a feature store provider, and if you're on AWS, there's SageMaker, there's also Tecton, there is also other feature store providers, and evaluating based on what are use cases and how easy it is to implement, and what are our main goals. Do we actually need high availability? Do we actually need low latency? And which of these tools are giving what we actually expect to get out of it? And then decide. And of course, how difficult it is to integrate with an existing environment should be also a decision maker, but it just shouldn't be the only one. Hey, we're already on AWS, let's use AWS SageMaker. Or we already have Databricks, let's use Databricks Feature Store. So I think it should be more flexible and open to all tools. That would be my answer to this.
Yeah, for startups, it's easier, much easier, but for large organizations, it's very painful to go through these processes. And yeah, then the cloud providers often win.
Yeah, usually in startups, so far I've worked mostly in startups, and in startups it's like we gather 3 dudes, and at some point we have to make a decision because you're pressured by time. And from my experience, usually the most important step is to take a decision. Like, most of the time. Maybe you won't take the best decision, but it's important to take
Yeah.
one decision, because from my experience, what I've realized so far is that if you do some research, most probably you won't pick like an extremely bad tool. And even if you don't pick the best tool, what you pick is good enough to do the job and move on.
Mhm. Yeah, and also
Yeah,
not to
and-
forget, tools change a lot. So you pick now, but like in half a year, they may have changed their roadmap, and they are now better than the other tool that you haven't picked, which was better in the beginning. So yeah, it's kind of gamble as well a bit.
Yeah.
Yeah, and one thing I think that's also important to take in consideration with all these third-party tools is what are you actually getting for the money that you are spending? Because I feel like some of the things that we used to do in simpler ways or could do in simpler ways are now being served by third-party tools. And when you look at the actual costs, they're pretty insane thinking of what it returns. So at a sort of ROI investment, I was at a conference in October and I saw an organization that was like doing MLOps in a state-of-the-art way. They were on SageMaker, but they were not using Feature Store. But they did have a Feature Store. They just built their own, just using SQL queries. And all these queries were in one utility Python package, which they could easily maintain and add all sorts of parameters and smart solutions. And it was a beautiful Feature Store. And it takes little investment to set this up. But actually gave so many advantages over this off-the-shelf turnkey solution that you would spend small capital on, or like big capital, but that's how we say it in Dutch. Yeah.
Thank you, Rafael.
Yeah, I would
Go
also
ahead, Paul. Go
like
ahead.
to add one last idea to this.
Mhm.
So, in my opinion, if you really want like to do your best research, is to take these tools and play with them. Like, I know, run some examples on your specific use case, run some simple examples, because if you just read the docs, you won't see the little details that will be when you actually start
Yeah.
to work with them.
I think, yeah, but I think it's not even enough just to play with it, because the worst part comes in integration, like networking and all that. That's where the most pain comes, and then it may have worked nice in your small POC, but yeah, the pain from integrations, it might be too much, and it's also very hard to test those things. It's a lot of effort.
Yeah, we actually have a specific use case at my client. I can go very into specifics, but the idea is that we decided just not to use a tool because we realized that no tool can do the like a little niche things that we need. No tool does that. So because we don't have the specific feature, it's just easier to build it from scratch than to drill down into the code and do some hijacking over there that probably in the long run will just be more complicated and spaghetti code. So yeah, I guess you really need to know what you need from your tools. So that's why the process is, to understand your process is the most important thing than the most shiny tool off the shelf.
Definitely.
Yes. For our audience, I added 2 articles in the chat. One of them is about deployment strategies written by Maria. And I also see a question in the list about cookie cutter template. I also added an article on that if you're interested in. And I will pick up a question from the list. What is the best open source third-party software to use for model and data bias monitoring? I personally always hesitate to answer the questions because there's usually no best. It's usually best for your use case, not best in the market. But feel free to answer.
Yeah, I also
Model and data bias monitoring.
I also think it's a very hard question to answer. There are many tools out there, and I don't think they're all completely open source. they all have some open source propositions, like evidently AI, we mentioned AnyML, so it's partially open source, but if you really want some cool features, you usually have to pay. And if you look at cloud providers, it's not really open source. They all also have some kind of features for that. But it really depends on the model. So I think if there is, if you have a target, so for example, if you have classification regression problem, you have a target you optimize for. Things like recommender systems are much harder to monitor because you don't really have the ground truth, not necessarily like in the way you have it in regression classification tasks. So those algorithms for data bias that are bound to the target cannot be used for recommender systems, which makes it more challenging. And if you're just going for, I don't know, for monitoring regression classification tasks, you could just as well use open source tools. Pretty much any of the tools have open source proposition that is good enough for that specific purpose. And then you can plug it in any open source monitoring tool. Like you could use Grafana, for example, to monitor whatever you need to monitor.
Yeah, I think honestly here the hardest part is how you gather your data. Like in my perspective, that's the challenging part here in monitoring, how you gather and cache all the predictions, inputs, and all of that to actually compute these metrics or whatever you need.
Yeah. So I hope this is answering your question, Manas. The next question. So what would be the starting point for building MLOps practices from scratch in a company that generally produces applications with ready-made APIs? So with low training load. This is from Gökar.
So it's interesting, the starting point from what point. Yeah, what we also talked about before in preparation for this, Paul, is how to actually convince your company to start investing on MLOps, or how to get the whole thing going. So that could be a starting point. But yeah, once you have the resources in place, maybe your question is more about that. What would be the technical starting point? But maybe you'd like to elaborate on this. Just wait for the answer. But it was also one of your questions, I think, Paul. Something we talked about last week. Just convincing an organization to start investing in MLOps.
Yeah. I actually have this issue myself right now, because most of the people don't really understand what MLOps is all about, and I'm talking like tech people, like software and machine learning people, that they like very focused on what they're doing. They're very good at what they're doing, but if you're not like curious to branch out into this space, you just, I know, you're not exposed to it and you don't know what is it about. And that's why I think those steps that you propose, like to understand some pain points and actually educate people on how MLOps can actually help solving these pain points, is like, in my opinion, the best way to go.
Yeah, so we got the response from Gökar. That's technical perspective, not political perspective here. So the question. So I think if it's a software company and you already have DevOps principles in place, which means you already have CI/CD pipelines, you already have some monitoring tools in place, most likely. So there are pieces that are different to MLOps compared to DevOps, and the one that is most important is the data. So the whole data versioning piece you probably don't have if you haven't done ML before. So I would invest into that piece. How do you make your data traceable? So also, if you are doing some ML, you need to have experiment tracking in place and the model registry. So that's a place where you register your model and see what the different iterations of your experiment were and how it's all connected to the data and to the code. So you haven't done that before if you're just starting with ML in the software company. So these pieces would be the most important ones, and monitoring would be another one. So monitoring, depending on what models you are doing, monitoring would be very different, because for different algorithms you're monitoring different things, and the data-driven monitoring would also be very different. But I would then use available tools, open source tools, and plug it into your standard monitoring tools, not to reinvent the wheel.
What I've seen here, I totally agree. But one issue that I've seen here is that many people use experiment trackers, but they forget like to actually hook this experiment tracking stuff to data registries and model registries, so they can actually have a full lineage on how the model was created. So I know, to be honest, why, but usually I have worked with unstructured data and images and text, and in that case it is not that straightforward to build a data registry and all of that. With structured data it's not easy, but there are many tools that give you these possibilities. But with unstructured data, when you have like terabytes of data, it's a hell to do it, and people get scared off, and they, I know, for some reason avoid this step, and they just move on and move on and move on, and they never have this like, okay, this model was created with this data, with this configuration and all of that.
Yeah, but so I think for this kind of unstructured data, hashes could work. So that's what I've seen. I haven't really worked with that type of data that much, but I would say that you check whether the hash is still the same. That would be the way to do it. Like if you have maybe a zip file or something containing all of that, it has a hash, and you could check against it as an option.
I think it is, but to be honest, I don't know how that works like at scale on big data. Like it's a question. To be honest, I never tried it. But what solutions I have seen is like tools like weights and biases, and I think also MLflow and all that. It lets you the possibility to build virtual artifacts on top of your data. So basically, you can store your data on S3, on file system or whatever, and you just put a virtual artifact that version. It's like basically a data registry. Every artifact is like a registry itself, so you can version it, add metadata, model schemas to it, and everything that you want inside of it. And doing so, basically you don't have to move the data around. You just, it's like a reference to where you store your data, but you can version it and track it basically. And then different jobs can ingest multiple artifacts and spit out other artifacts. And in this way, basically you have a full lineage on all your runs and versions and all of that. So far, this is the best strategy that I've seen to solve this.
Yeah.
Thank you for the answer and for the discussion. We're actually coming to the end. I would ask Maria and Rafael if you have any questions for our guest, Paul. One last.
That's a good one. I haven't prepared any question. Rafael, have you prepared a question?
Well,
I can go if
You
you can also go.
you don't have any. I just wanted to be polite and ask you first, and then I can get my round. I really like the courses that you create. Paul. My one question is, in your words, what is the biggest difference between MLOps and LLMOps?
I'm really happy to hear that from you. Well, the biggest difference is I think that in MLOps, the biggest issue is that you work with big models, so and with unstructured data usually, because when you model unstructured data, usually you want big models, and they usually come hand in hand. Not always, but usually. And when you're using big models, it comes with a lot of issues on your infrastructure side, because you need not one big GPU, usually needs 2, 3, 5, 10 big GPUs. So it's harder to manage your infrastructure, and it's very costly Like you can kill thousands of dollars in a few days if you're not careful. So this is a very big issue with MLOps. This is the first thing. The second thing is training time. So usually you can train for days, weeks, months. So you have to be very careful what you're doing. And just imagine you're saying, hey, let's do this experiment for 2 weeks. And after 2 weeks, you saw that it's complete rubbish what you've done, but you've just spent $10,000 on that experiment. So like your decisions are more, have a lot more impact on your resources, let's say. So you don't have so much freedom to move, I would say. Thank you.
No.
Thank you, Manas. Really glad to hear that. So we currently at Metaphysic, the client that I have, we are not really working with LLMs, but we work with face swap models, which are also quite big, and they need to train sometimes for 2-3 weeks. And yeah, I see this problem very, very often, that resources and training time. And I wouldn't say that it's a problem that is completely solved.
Yeah, I agree. It's a very valid answer. Okay, so we have the last 2 minutes. If there are any final questions or remarks.
Yeah.
And actually,
yeah, you go.
I would like to add one last thing. It's when you work with a generative AI, which is usually attached to this LLM trend, it's very hard to monitor and compute metrics on your data. Like sometimes you just don't do that at all. You just look at it and say, okay, it's good enough, because it's just hard, especially with this computer vision generative AI party. You just no. It's like a very open research field how you evaluate what you've done there.
Today I was actually looking at your post on how to evaluate LLMs in 3 different ways. So you actually have already nice suggestions on that. I can recommend our audience to check it out.
Yeah. For text, but for visual information, it's harder.
True. All right, we're in the last 60 seconds. Any final remarks or very short questions, Maria, Rafael, Paul?
Well, I don't know if you can do it in 60 seconds, Paul, and no less, but
I'll do my best.
you're doing this cutting edge freelance work, and you're making all this great content. And I was just kind of wondering, like, where do you see yourself going from here?
Very good question.
Thank you to ask me that. Well, actually, I just want to grow like tech-wise, in my contracting business-wise. So basically, usually I try to find bigger and bigger projects that I can work on, and usually I want to stick to this niche of generative AI and MLOps as much as possible, because this is where I see the future. And like content creation-wise, actually, I just started to expand my like decoding ML brand. I started to convince two friends to come and also write with me on Medium. I will start like a Medium publication, and also on Substack. Basically, I will do intermittent articles with them and all of that. So this is like my near future plan. And in the long run, to be honest, it's hard to think, but I usually try to keep things simple and just follow my curiosity. I guess usually I was never afraid like to do what my gut tells, and if something I don't know sounds interesting, just do it and see what happens.
Yeah, great stuff. We'll keep following you.
Definitely. Yeah. And thank you for your honest answer as well. It's been a quiet session. I would like to thank our audience for participating and sending us questions. And Paul, thank you for also joining and answering questions with us. We hope to have more sessions in the future and more guests in the future, so stay tuned. And I wish everyone a great holiday season and a great New Year's.
Awesome. I'm really happy to that I had this chat with
Happy
you,
holidays.
and I'm really glad you invited me. Happy holidays.
Happy holidays, everyone.
Of course.
Thank you.